What happens when you take a luxury car engine, stuff it in a mid-size body, and accidentally invent the muscle car? You get the 1949 Oldsmobile Rocket 88, a car so revolutionary that it made every other manufacturer's lineup look like they were still building horse carriages. This is the story of how one engine didn't just win races. It rewrote the entire automotive rulebook. Picture this. It's 1949, and you pull up to a stoplight in your brand-new Rocket 88. Next to you, some poor soul in a Cadillac, the supposed king of American luxury, revs his engine. He's got confidence. After all, he paid twice what you did. The light turns green. By the time he realizes what just happened, you're already 3 car lengths ahead and pulling away hard. His jaw drops. Yours doesn't. You knew exactly what 135 horsepower and 263 pound-feet of torque could do in a car that weighed 600 pounds less than his land yacht. The Oldsmobile Rocket 88 wasn't supposed to exist. It was born from a corporate accident, a last-minute decision that would define American automotive culture for the next 3 decades. General Motors never intended to create the first muscle car. They were just trying to give Oldsmobile something interesting for 1949. What they actually did was light a fuse that would explode into the horsepower wars of the 1960s. To understand why the Rocket 88 shocked the automotive world, we need to travel back to 1948. America was 3 years out of World War II, the boys were home, the economy was booming, and everyone wanted a new car after years of rationing and making do with pre-war models. The problem? Most manufacturers were still thinking like it was 1941. Ford was cranking out updated versions of their pre-war designs. Chrysler was focused on engineering excellence, but forgot to make their cars exciting. Even within General Motors, the divisions were stuck in rigid hierarchies. Chevrolet built cheap cars for the masses. Pontiac was a step up. Buick meant you'd made it. Cadillac? That was for the truly wealthy. And Oldsmobile? They were stuck in the middle, building solid, respectable cars for middle managers and dentists. The automotive pecking order was based on one simple principle: size and luxury determined status. Bigger engines went in bigger cars that cost more money. It was a system that had worked since the 1920s. Nobody questioned it. Why would they? If you wanted to go fast, you bought a big car with a big engine. Physics demanded it, or so everyone thought. But here's where things get interesting. Oldsmobile's engineers had been working on something special, a completely new V8 engine designed from scratch. Not an update of an existing design, not a bored-out version of something from the 1930s. This was clean-sheet engineering with one goal: maximum efficiency and power from a compact, lightweight package. The engine that emerged from Oldsmobile's Lansing, Michigan facility was revolutionary. Designated the Rocket V8, it displaced 303 cubic inches. That wasn't huge by the standards of the day. Cadillac's V8 was 331 cubic inches. But the Rocket's design was radically different. It featured overhead valves instead of the side valve configuration most manufacturers used. The compression ratio was 7.25:1 when most engines ran 6.51 or lower. The bore was 3.75 inches with a 3.44-inch stroke, over square dimensions that let it rev higher than traditional long-stroke designs. The cylinder heads were the real innovation. Engineer Gilbert Burrell had designed them with larger valves and better port flow than anything in production. The combustion chambers were wedge-shaped, promoting better flame propagation. The valve train was lighter and stiffer than competitors, allowing higher RPM operation without valve float. Even the short-stroke design was revolutionary. Everyone else was building long-stroke, low-revving torque motors. Oldsmobile built a screamer. In its initial configuration, the Rocket V8 produced 135 horsepower at 3,600 RPM. That might not sound impressive today, but consider this. Ford's flathead V8 made 100 horsepower from 239 cubic inches. Chevrolet's top engine produced 90 horsepower from 216 cubic inches. Even Cadillac's larger V8 only made 160 horsepower, and it weighed significantly more, but horsepower was only part of the story. The Rocket V8 weighed just 575 pounds, fully dressed. Cadillac's engine tipped the scales at nearly 700 pounds. That weight savings meant better handling, better braking, and better acceleration. It was a complete system advantage, not just a power upgrade. Now here's where corporate accident meets destiny. The Rocket V8 was originally intended for Oldsmobile's big 98 series, their Cadillac fighter. It made sense. Big engine for a big car. Follow the hierarchy. Don't rock the boat. But then someone had a crazy idea. Jack Wolfram, Oldsmobile's general manager, was looking at the sales numbers. The lighter, smaller 76 series, soon to be renamed the 88, was popular but boring. What if they dropped the Rocket V8 into that lighter body? The engineers ran the numbers. A 3,600-pound car with 135 horsepower would have a power-to-weight ratio that destroyed everything in its price class. Hell, it would embarrass cars costing twice as much. Wolfram gave the green light. General Motors management, not fully understanding what they were unleashing, approved it for 1949 production. The 1949 Oldsmobile 88, they added Rocket to the name almost immediately, hit showrooms in late 1948. The body was Oldsmobile's new Futuramic design, lower and sleeker than previous models. But buyers didn't care about the styling. They cared about what happened when you pressed the accelerator. 0 to 60 took 13 seconds. That's laughable now, but in 1949, it was supercar territory. The quarter mile fell in 18.5 seconds. Top speed pushed past 95 miles per hour. More importantly, the Rocket 88 could cruise at 70 miles per hour all day long without breaking a sweat. Try that in a flathead Ford, and you'd be stopping for water every 50 miles. But raw performance was only part of the equation. The Rocket V8's smooth power delivery transformed the driving experience. Overhead valves meant better breathing at all RPM. The short stroke reduced piston speed at any given RPM, decreasing wear and improving reliability. The over-square design reduced internal friction. Everything about this engine was more efficient than the competition. The transmission was another advantage. Oldsmobile's Hydra-Matic automatic, the first truly successful automatic transmission, was perfectly matched to the Rocket V8's power curve. While Ford buyers were still rowing through 3-speed manuals, Rocket 88 owners just pressed the gas and went. The combination of overhead valve V8 and automatic transmission created the template for American performance cars that would dominate for decades. NASCAR noticed immediately. The Rocket 88 dominated the 1949 season, winning 6 of the 8 races. Red Byron piloted 1 to the championship. In 1950, it got worse for the competition. Rocket 88s won 10 of 19 races. Bill Rexford took another championship. By 1951, Oldsmobile had won 20 of 41 NASCAR races over 3 seasons. No other manufacturer came close. The Mexican road race, the Carrera Panamericana, saw similar domination. Rocket 88s finished first and second in the stock car class in 1950. They won again in 1951 and 1952. This wasn't just circle track dominance. The Rocket 88 proved itself on road courses, in endurance races, on drag strips. Anywhere speed mattered, Oldsmobile was winning. The sales numbers tell the real story. In 1948, Oldsmobile sold 178,000 cars total. In 1949, with the Rocket 88 leading the charge, they sold 288,000. By 1950, Oldsmobile had climbed to 4th place in sales, behind only Chevrolet, Ford, and Buick. The Rocket 88 alone accounted for nearly 270,000 units in 1950. Buyers were voting with their wallets, and they wanted performance. Let's dive deeper into what made the Rocket V8 so special. The overhead valve design was critical. In a flathead engine, the valves sit beside the cylinder, in the block. The combustion chamber extends into the block, creating a long, thin space that's terrible for efficient combustion. The flame front has to travel a long distance. Heat is lost to the large surface area. The gas flow path is tortuous, limiting breathing. Overhead valves put the valves above the piston in the cylinder head. The combustion chamber is compact, promoting faster, more complete combustion. The gas flow path is direct, straight down through the intake valve, straight up through the exhaust valve. The Rocket V8's wedge-shaped combustion chambers were particularly efficient. The spark plug sat on one side, creating a short flame travel distance to the far edge of the chamber. The valve sizes were impressive for 1949. Intake valves measured 1.875 inches. Exhausts were 1.5 inches. Compare that to Ford's flathead with its 1.5-inch intakes and 1.4-inch exhausts, remembering that the Ford's side valve configuration already restricted flow. The Rocket V8 could breathe in a way flatheads simply couldn't match. The valve train was equally advanced. Hydraulic lifters eliminated the need for periodic valve adjustments. This was still exotic technology in 1949. Most engines required valve lash adjustments every few thousand miles as components wore. The Rocket V8 just ran, mile after mile, maintaining perfect valve timing automatically. The bottom end was overbuilt by design. The crankshaft was forged steel with 5 main bearings. Many competitors used 3 or 4. The connecting rods were forged steel as well. The pistons were aluminum, reducing reciprocating weight. Every component was designed for durability at sustained high RPM. Cooling was another innovation. The water pump was gear-driven off the camshaft, ensuring positive drive without belt slippage. The radiator was oversized for the application. Oldsmobile engineers had learned from airplane engines during the war. Cooling capacity needed reserves for extreme conditions. The oiling system reflected similar attention to detail. Full pressure lubrication reached every bearing surface. The oil pump was gear-driven, again ensuring positive drive. An oil filter was standard equipment when many manufacturers still considered it optional. The oil capacity was 6 quarts, providing thermal mass to prevent overheating under hard use. But the real genius was in the integration. Every system supported every other system. The efficient combustion reduced heat load on the cooling system. The good breathing reduced pumping losses, improving fuel economy. The smooth power delivery reduced stress on the drivetrain. The automatic transmission eliminated the shock loads of clutch engagement. It was systems engineering before anyone used that term. The carburation deserves special attention. Oldsmobile used a 2-barrel Rochester carburetor, Model B. This wasn't high-performance hardware by later standards, but it was perfectly sized for the engine. The primaries provided excellent fuel atomization for smooth idle and cruise. When you floored it, both barrels opened, delivering enough fuel for maximum power. The accelerator pump shot was calibrated to prevent stumble during rapid throttle opening. The ignition system was conventional but robust. A single coil fired all 8 cylinders through a distributor. Points and condenser controlled spark timing. But Oldsmobile specified heavy-duty components throughout. The distributor featured centrifugal advance for optimal timing across the RPM range. Vacuum advance improved fuel economy during light throttle cruise. The exhaust system was surprisingly sophisticated. Cast iron manifolds collected exhaust from each bank. But instead of the restrictive single exhaust common at the time, Oldsmobile fitted a larger diameter system with a straight-through muffler. This reduced back pressure, allowing the engine to breathe freely. It also created a distinctive sound, not loud, but purposeful. You knew a Rocket 88 was coming before you saw it. Now, here's the kicker. While Oldsmobile was revolutionizing performance, they accidentally revolutionized automotive culture too. The Rocket 88 wasn't marketed to wealthy buyers. It was priced for the middle class, about $2,000 in 1949, roughly $24,000 in today's money. Suddenly, the average Joe could blow the doors off a Cadillac. Performance became democratic. This democratization had profound effects. Young buyers, previously ignored by manufacturers, suddenly had something to aspire to. The used car market exploded as teenagers sought cheap Rocket 88s to modify. Speed shops popped up to service this new market. Hot rodding, previously a California phenomenon, spread nationwide. The music industry noticed. Ike Turner's Rocket 88, recorded in 1951, is often cited as the first rock and roll song. The lyrics celebrated the car's performance. "Yes, it's great, just won't wait. Everybody likes my Rocket 88." The car had become a cultural icon in just 2 years. The competition scrambled to respond. Chrysler rushed their firepower Hemi V8 into production for 1951. It made 180 horsepower from 331 cubic inches, finally matching the Rocket's power-to-weight ratio. But Oldsmobile had a 2-year head start and massive momentum. Ford's response was particularly panicked. Still committed to the flathead V8, they bored it out to 255 cubic inches for 1953, extracting 125 horsepower. It was too little, too late. Ford wouldn't have a proper overhead valve V8 until 1954, 5 years behind Oldsmobile. Within General Motors, the Rocket V8 created chaos. Cadillac was furious that a cheaper Oldsmobile could embarrass their luxury barges. Buick demanded their own high-performance engine. Even Chevrolet, supposedly the value brand, started development of what would become the small block V8. The corporate hierarchy that had defined GM since the 1920s was crumbling, but Oldsmobile wasn't standing still. For 1951, the Rocket V8 grew to 324 cubic inches and 165 horsepower. The new Super 88 model positioned between the standard 88 and the luxury 98. By 1952, power reached to 170 horsepower. The 1953 models pushed 175 horsepower. Each year brought improvements: better breathing, higher compression, improved cooling. The Quadrajet carburetor arrived for 1952, replacing the 2-barrel unit on high-performance versions. This 4-barrel carb could flow 600 cubic feet per minute, supporting well over 200 horsepower. Oldsmobile was thinking ahead, building in growth capacity. The J2 option appeared in 1957, 3 2-barrel carburetors delivering 300 horsepower from 371 cubic inches. This was serious hot rod territory. A properly equipped J2 Rocket 88 could run the quarter mile in under 15 seconds, embarrassing supposed sports cars. Costing 3 times as much, the transmission evolved too. The original 4-speed Hydramatics gave way to the new Jetaway Hydromatic in 1956. This featured a fluid coupling instead of a torque converter, providing more direct power transfer. Shift points were revised for performance. The combination of J2 engine and Jetaway transmission created a formidable street fighter. But the real legacy wasn't in specific models or options. The Rocket 88 proved that Americans wanted performance, would pay for performance, and would choose performance over luxury if forced to decide. Every muscle car that followed, from the Pontiac GTO to the Plymouth Roadrunner to the Chevrolet Chevelle SS, traced its DNA back to that first Rocket 88. The overhead valve V8 became the standard for American performance. By 1955, every major manufacturer offered one. The flathead was dead. Side valve engines disappeared except in the cheapest economy cars. The engineering principles Oldsmobile pioneered over square dimensions, overhead valves, hydraulic lifters, high compression became industry standard. The cultural impact was equally profound. The Rocket 88 created the youth market. Before 1949, young buyers got hand-me-down sedans from their parents. After the Rocket 88, they demanded performance. The Beach Boys sang about it. Hollywood featured it. The American obsession with speed and power traces directly back to those first Rocket 88s, leaving dealers in 1949. So what was actually going wrong at other manufacturers while Oldsmobile dominated? Ford's commitment to the flathead V8 bordered on religious. Henry Ford had personally developed it in 1932. Abandoning it meant admitting the old man was wrong. Not until Henry Ford II fully took control in 1953 could Ford engineers develop a modern engine. Chrysler had the engineering talent but lacked Oldsmobile's courage. Their engineers had designed overhead valve engines in the 1930s, but management deemed them too expensive. Only when the Rocket 88 started eating their sales did Chrysler unleash their engineers. The resulting Hemi V8 was brilliant, but late. Even within GM, politics prevented rapid response. Chevrolet engineers had proposed overhead valve V8s repeatedly. Management said no. Chevrolet buyers wanted economy, not performance. The Rocket 88's success finally convinced them otherwise, but Chevrolet's small block V8 didn't arrive until 1955, 6 years after Oldsmobile showed the way. The aftermarket industry exploded around the Rocket V8. Offenhauser created aluminum heads flowing 20% more air. Iskandarian ground camshafts with radical profiles. Edelbrock cast high-rise intake manifolds. Multiple carburetor setups appeared, some running 6 two-barrels. Superchargers bolted on, pushing output past 400 horsepower. Drag strips became proving grounds for modified Rocket 88s. The engine's robust bottom end handled nitrous oxide and supercharging. Its good breathing responded to headwork and cami. Changes. A cottage industry emerged, building rocket-powered dragsters that dominated into the 1960s. But the real story wasn't just the racing or the street performance. The Rocket 88 changed how Americans thought about cars. Before 1949, cars were transportation or status symbols. After the Rocket 88, they could be both, and something more. They became expressions of freedom, youth, rebellion. The open road called louder when you had 135 horsepower under your right foot. The reliability was remarkable for such a high-performance engine. Rocket V8s regularly ran 100,000 miles without major work. In an era when most engines needed rebuilds at 50,000 miles, this was revolutionary. Taxi companies bought Rocket 88s, proving that performance and durability weren't mutually exclusive. The fuel economy, while not a primary concern in the era of 25-cent gasoline, was surprisingly good. A Rocket 88 could achieve 20 miles per gallon on the highway. A Ford with similar performance, if you could find one, drank fuel at 15 mpg. The efficiency of overhead valves and better breathing paid dividends everywhere. Let's talk about the competition that tried and failed to match the Rocket 88. Hudson brought out their 308 cubic inch straight six, making 145 horsepower. It was powerful but heavy, and straight sixes had image problems. Americans wanted V8s. Hudson sales collapsed. Studebaker developed their own overhead valve V8 for 1951, displacing 232 cubic inches and making 120 horsepower. It was modern and efficient, but too small. Buyers wanted cubic inches. Studebaker never recovered from this miscalculation. Nash tried a different approach with their Ambassador, stuffing a 234 cubic inch straight six under the hood, making 115 horsepower. They emphasized luxury and comfort over performance. The market ignored them. Nash merged with Hudson to form American Motors, a marriage of two companies that missed the performance revolution. Kaiser Frazer didn't even try to compete. They focused on styling and features, believing Americans would choose fashion over function. They were catastrophically wrong. Kaiser Frazer left the U.S. market in 1955, victims of not understanding what the Rocket 88 had taught everyone else. Americans wanted to go fast. Even luxury manufacturers felt the pressure. Packard, once America's premier luxury brand, found their straight eights embarrassed by Rocket 88s. They rushed a V8 into production for 1955, but it was too late. Packard's reputation never recovered from being outrun by cars costing half as much. The engineering influence spread globally. European manufacturers studied the Rocket V8, amazed at its specific output and efficiency. Mercedes-Benz engineers reverse-engineered Rocket 88s, incorporating overhead valve designs into their own engines. Even Ferrari acknowledged American V8 superiority in certain applications. By 1955, the Rocket 88's influence was complete. Every American manufacturer offered overhead valve V8s. The horsepower race was in full swing. Compression ratios climbed toward 10.1. Power outputs pushed past 200 horsepower. The template Oldsmobile created, efficient breathing, high compression, over square dimensions, defined American performance for the next 2 decades. But here's where the story takes an interesting turn. Success bred complacency. By the late 1950s, Oldsmobile had lost its performance edge. Other divisions caught up and passed them. The small block Chevrolet proved cheaper to build and modify. The Pontiac V8 grew larger and more powerful. Chrysler's Hemi and wedge engines dominated drag racing. Oldsmobile tried to maintain relevance with innovations like the turbocharged Jetfire in 1962, but reliability problems killed it. They developed the W31 high-performance package, but it couldn't match the publicity of Pontiac's GTO or Plymouth's Roadrunner. The brand that invented the muscle car became a has-been in the muscle car era. The final Rocket V8 rolled off the assembly line in 1990, ending a 41-year run. By then it was an anachronism, a push-rod relic in an era of overhead cams and fuel injection. But every modern American V8, from the Corvette's LT2 to the Hellcat's supercharged Hemi, carries DNA from that original rocket. Today, original Rocket 88s are coveted collectibles. A pristine 1949 model can command $50,000 or more. The rare J2-equipped cars from 1957 sell for 6 figures. But the real value isn't monetary. These cars represent a pivotal moment when American automotive culture discovered speed. The Rocket 88 proved that performance sells. It showed that young buyers mattered. It demonstrated that engineering excellence could overcome corporate hierarchy. It created the template for every performance car that followed. Not bad for an engine that was supposed to go in a luxury car. When you see a modern Dodge Challenger rumbling down the street, or a Corvette shrieking around a track, or even a Tesla silently destroying supercars at stoplights, remember the Rocket 88. It started the American obsession with going fast. It democratized performance. It proved that in America, anyone could be king of the road if they had the right engine. The Oldsmobile Rocket 88 didn't just outsmart every competitor in the 1950s. It rewrote the rules of what a car could be. It transformed transportation into passion. It turned machinery into culture. And it proved that sometimes the best innovations come from breaking the rules everyone else is following. That's the legacy of the Rocket 88, not just the wins on Sunday or the sales on Monday, but the fundamental shift in how Americans related to their cars. Before 1949, cars got you there. After the Rocket 88, getting there became half the fun. The other half? Showing everyone else your taillights. What's your favorite piece of 1950s automotive innovation? Drop a comment below and let's talk about the golden age of American performance. And if you enjoyed this deep dive into the engine that started it all, make sure to subscribe because we're just getting started exploring the machines that changed the world.